Okay, can we start? Okay, I think we can start. Good afternoon, everyone, and welcome to the panel, the Chip War. My name is Eduardo Campanella. I'm a senior fellow at the Mossovar Center for Business and Government, and I have the pleasure to moderate this panel on one of the hottest topics of the time. I'm joined by two friends, John Hai, who's very well known here at HKS. He's the co-director of the Mossovar Center, professor here. Besides his scholarly knowledge, he also brings to the table a real-world experience that I think is very relevant for this kind of topic, because he spent many years working. Okay, maybe we can use this. Okay, he spent several years working in the telecom industry as very senior executive roles. And so I think his experience will be very important for our discussion. And then on my left, Chris Miller, that is now a sort of rock star of this topic. He's a professor at Fletcher School and author of this book. Some of you were lucky to get a free copy. That is having an extraordinary success. Any article on the chips industry, one way or another, refers to his book. The timing was exceptional, I think, for the publication, because it was exactly in between the approval of the CHIPS Act and the export ban on the semiconductor sold to China. The way we are structuring the discussion is the following. We first start talking about his book, then we will broaden the discussion and talk about current events also with John. My first question to Chris is the following. The semiconductor industry is one of the most complex industries in the world, and it is very fascinating because of its geopolitical and macroeconomic implication. What I think is interesting is that, from an economist perspective, is that it is one of the most internationally integrated industries in the world, because the different phases from research, design, production, and assembly are spread across the world in North America, Asia, and somewhat Europe. But it's also one of the most concentrated industries in the world, in the sense that there are a few actors that play a disproportionate role. And if something happens to them individually, the whole industry gets disrupted. So since not everyone is an expert of the topic, I think it would be interesting if you could give us a brief overview of the structure of the industry and the key actors internationally. Thanks.
Yep. Well, thank you for the invitation to join today and to kick off this discussion. Most of us, at least me before I started writing this book, and most of you in the audience don't really think that often about semiconductors, but semiconductors do a lot of thinking for you. The typical person will touch thousands of semiconductors over the course of their daily life without seeing any of them, unless there's an electrical engineer in the room who happens to tinker with one in a device. You wake up in the morning, your alarm clock has a semiconductor inside, brew coffee, your coffee machine has a semiconductor inside, your dishwasher, your washing machine, get in a car, and it'll have hundreds, or in some cases thousands of chips inside. And that's even before you've touched a device that you think of as having computing power. But today, almost all devices have some amount of computing power inside of them. And today, computing power is impossible to produce without semiconductors, which is why we're more reliant on them than ever before. And as you said, the process of producing advanced semiconductors is the most complex manufacturing process in human history, bar none. And that makes it very, very difficult to do. And it's only possible to produce advanced chips like the one, if you buy a new iPhone 14, it'll have a main processor chip that is 15 billion tiny transistors carved into it, each one smaller than a coronavirus. They're manufactured with basically perfect accuracy by the billions and billions and billions. I learned a new number while researching this book called a quintillion, which is the number of transistors that were produced by one Taiwanese company, tsmc, just to produce the main processor chip on iPhones. A quintillion is numbered with 18 zeros after it. And that's the number of transistors globally in just one type of chip. And your iPhone will have many chips inside of it. So this is really, really hard manufacturing. And as you say, it takes a complex supply chain to do so. So there's machine tool makers that are able to produce the machines that can manipulate materials at literally the atomic level. And there are 5 main machine tool makers, 3 in the US, 1 in the Netherlands, 1 in Japan, without which it's impossible, simply impossible to produce advanced chips. There are 3 companies that dominate the industry that produces the software that designs chips, all based in the US. And then there are a small number of firms that are capable of actually doing the manufacturing of advanced chips. And the most important of them is the Taiwan Semiconductor Manufacturing Company, which produces 90% of the world's most advanced processor chips. All of them today are produced in Taiwan. And they produce over 1/3 of the computing power added in the world each year. One company on one island produces 1/3 of the world's additional computing power, which is an extraordinary situation to find ourselves in, both because of the concentration and also the location of that concentration, which I'm sure we'll talk about over the course of this discussion.
Thank you. So yes, I think what's interesting is that the current structure is not the result of random dynamics, but of a clear historical evolution. And I think the reason why this book is interesting is that it's one of the few, probably the only one, that provides a detailed description of this historical development. I think, I think it would be interesting for us to understand what were the key moments in this history that started probably in the early 50s or maybe slightly before that. If you have to pick 3, 4 key events that are essential to understand where we are now, what would you pick?
So I'd start with an event that happened 75 years ago this month, which is the invention of the transistor, which is a tiny electric circuit that turns on or off. If it's on, it's a 1. If it's off, it's a 0. And this produces all of the 1s and 0s, undergirding all computing, all memory of data. And when the first transistors were produced, they were visible, so large you could see them. And now they're so small, they're measured in nanometers. So it's only been 75 years since we first invented the transistors, to the point where we produce more of them every day than there are cells in the human body. We produce more transistors just this year than the combined total of all of the manufactured goods in all human history combined. So that would be the first key turning point. The second was the commercialization of the transistor, because it's one thing to create a scientific invention, but a very different thing to find a way to sell it in a sustainable manner. And the first customers for transistors and then chips, which are just devices with multiple transistors in them, was the Pentagon. It was the demands to have more accurate missiles that drove the miniaturization of computing power. Because if you're a big company, you can afford to have a room full of computer, but if you're designing a missile, you can't fit a room-sized computer in the nose of that missile. And so there was a deep interrelationship between military demands, the missile race with the Soviet Union, and the development of miniaturized computing power that spawned the chip industry. So that's the second key turning point. The third, I think, was the internationalization of the chip industry. And I want to stress here, I think there's a false term called globalization, which is often applied to the chip industry. And that is just a complete empirical lie. There's no globalization at all in the industry. There are 5 countries that produce all of the key components and tools needed in the chip industry. And yet those 5 countries have been deeply engaged in the chip industry for a very long time. And so the first chip was produced in the late 1950s. And just 3 years later, one of the first Silicon Valley chip makers opened their first assembly facility in Hong Kong. And so there's been a deep interrelationship between the US and Asia for assembly and then later fabrication of chips since the early 1950s. And that was another key turning point. It's developed and deepened over time. Then finally, one more recent turning point, which is the period about 5 to 7 years ago when TSMC, the Taiwanese firm that I mentioned, jumped ahead of Intel, which used to be the world's most advanced chip maker, a US firm, in terms of their capability of producing the most advanced chips. And up until that point, American policymakers, business people could tell themselves they had the most advanced chip making in the world because it was true. And now it's no longer true. Today, the entire world depends on Taiwan for the most advanced chip making, which has had major commercial ramifications benefiting TSMC to the detriment of Intel, but has also had major geopolitical ramifications, which is why today you see political leaders from the US to Japan to Europe to China thinking much more about semiconductors than they ever had before.
Yeah, thank you. And if I may, I would probably add a fifth element that is the geopolitical competition between great powers that certainly played a role in the acceleration in the development of the industry. In the book, you talk about the competition between the US and the Soviet Union and the competition between the US and Japan. With the Soviet Union, there wasn't competition in the end, because basically you argue that they were just trying to copy what the US was doing. And by the time they were mastering a new technology, that technology was already outdated. So they were always behind the US. When it comes to Japan, Japan was a real competitor. In the book, somewhere you say that an prominent Japanese said that while the Americans in the 80s were churning out an army of lawyers, in Japan they were just training engineers. And the result of this competition was that Intel was forced to abandon the market of memory chips and had to focus on microprocessor. The decision was rewarding in the end, but it was very costly for Intel, because Intel had to go through a radical internal restructuring. When it comes to China today, do you think China, is it fair to argue that the competition with China is somewhere in between the competition with the Soviet and Japan, or would you describe it in a different way?
So I think I would compare China actually to the efforts of Taiwan and South Korea to jump ahead in the chip industry, because 40 years ago, both Taiwan and South Korea played a really marginal role in the chip industry. They had pretty low value portions of the supply chain, a lot of assembly and testing, which has traditionally been low tech. And in both countries, governments and industry leaders made a really concrete effort over the past several decades to catch up. And they did so in a really specific set of ways. One, there were very supportive government policies in terms of tax incentives, in terms of education, that were designed to provide as favorable a business environment as possible. But two, the key companies in both Taiwan and South Korea integrated very, very, very deeply into international supply chains, trying not to replicate the entire supply chain, but focused on one niche where they could do really well. And so they learned from their suppliers, they learned from their customers, and they were able to do so because they were deeply plugged in. And that was the strategy that a lot of Chinese firms until recently had tried to pursue. If you look at SMIC, for example, the leading Chinese chip maker, in the first decade of its existence, it essentially functioned like a company little different from any other in the semiconductor supply chain globally. But today that's becoming much harder to do, both because of policies in Washington and because of policies in Beijing. And so now China is finding itself in the position of the Soviet Union, partly by choice, partly by US design, where it's got to try to do it all on its own. And that is going to be a very, very difficult task. And there's no great historical precedent for success. There's definite historical precedent for success in replicating what Taiwan did, replicating what South Korea did. But that model is no longer valuable to China. And so the question is, can China do something far harder than what South Korea did or Taiwan did? And that's just going to be a very difficult task to undertake.
Yeah, we will talk about China in a second, more in detail. I have one final question, then we move to John. What makes your book interesting is that the writing style is very engaging, and you refer to a lot of interesting historical anecdotes. And you depict also in details some of the key figures of the industry. I can say that probably your hero from the book is probably Morris Chang, who is the founder of the Taiwan semiconductor industry. Can you just briefly tell us why you think he's so important to understand where we are now today?
It's actually somewhat, I think, controversial to talk about Morris Chang at Harvard, because he was a student here for 1 year and then left for MIT. One of the most embarrassing moments in Harvard's history, sadly. He'd been born in China before the war, spent the war fleeing Japanese armies, lived in Hong Kong at some point, and Chongqing during the war. Then when the communists took power in 49, he fled again and enrolled at Harvard as an undergraduate, the only Chinese student in his class, studied English literature and Shakespeare for a year until his uncle told him to study something useful. And so he went to MIT instead, where he studied physics and electrical engineering, and was hired by a company nearby called Sylvania, which is in the electronics industry of that day, one of the major players, then was later hired by Texas Instruments, which was the hot startup of the mid 1950s, and played an absolutely seminal role in learning how to manufacture chips. Because the hard thing to do in the early days of the chip industry was how do you actually manufacture them so they work? And he was notorious at TI for his attention to detail, his brilliant intuition at manufacturing effectively. And he rose very rapidly in TI until in the 1980s, in the early parts of the decade, he was thought to be a contender to be the next CEO. But in one of the great errors of business history, he was passed over for the CEO job and left the company. And in the 1980s, well, in his 50s, was looking for a sort of second act in his career. He'd already done very well in business, but was looking for something new. And the Taiwanese government approached him. And he'd been to Taiwan before only on business trips, because Texas Instruments had a couple of facilities in Taiwan. And the Taiwanese government offered him a blank check to start a semiconductor industry in Taiwan. And he had a new business model idea. Before that point, all chips were designed and manufactured by the same companies. And he said that this was an inefficient way to do business. Manufacturing required different techniques than design. And he wanted to become the Gutenberg, if you will, of semiconductor manufacturing. So today you can write a book on to print it yourself, and that's exactly what he does. His company, TSMC, just prints chips, doesn't design any in-house, and that has enabled them to serve a much broader array of customers, and as a result, produce more chips. And as TSMC has produced more chips, they've honed their process and reached the position today where they have the most technologically advanced process of any company in the world. So I think Morris Chang is a person that we all have to study very carefully. He's now officially retired from his role as chairman of TSMC, although when I last spoke with him, it was in a TSMC office. So I don't think he's fully understood the meaning of retirement. But he's an extraordinary entrepreneur, an extraordinary character in understanding the individuals who have linked together the US and the Asia Pacific region and kind of personally built the globalization that we take for granted today.
Thanks. Maybe your next book could be his biography.
Well, he's actually writing an autobiography right now, so I'll let him publish that first.
Okay. So, and it's fair to argue that if he had been offered that job as CEO of Intel, maybe the world today, Texas Instrument, maybe the world today would be completely different, because
well, TSMC could stand for the Texas Semiconductor Manufacturing Company.
Exactly. So let's now talk about more current events. I think the US over-dependence on Taiwan for the production of advanced chips can be considered a strategic mistake similar to Germany's over-dependence on Russian natural gas to some extent. And now the Biden administration is trying to fix the problem and build some domestic capabilities, domestic resilience. So, and the key legislation in that sense is the Chips and Science Act. John, in your opinion, is the Chips Act capable to revamp the semiconductor industry here in the US?
So thanks, Ido. So just a little bit of background before I answer Ido's question. So he's right, and half right in his description of my background. I actually don't consider myself particularly academic. My experience was I was president of AT&T's international operations, and I was senior vice president for AT&T Wireless's emerging initiatives, which is basically new services in the wireless industry, and then ended up finding my way back to the Kennedy School as the executive dean, and as co-director of the center, I co-direct with Larry Summers, which leads to some incredibly interesting discussions about these kinds of topics. And when you think about the context that we're talking in the question that Ido raises, part of what's happened is that there was this long history of increasingly rapid economic integration on a global basis. And so you had these complex supply chains being built that were heavily integrated on a global basis. And I think the semiconductor industry, as Chris went through, is clearly like one of the most complicated global supply chains you could imagine. And so when you think about in the book, I strongly encourage you to read the book because it's a terrific read and it's a fun read and you learn a lot when you go through it. But if you think of something like extreme ultraviolet lithography, there's really one company in the world that can do that, ASML, which is a Dutch company. Okay, and when you think about when TSMC was formed, if I remember the numbers right, something like 50% of the investment capital came from the Taiwanese government. 30% came roughly from some wealthy Taiwanese individuals that the government strong-armed. And I think the other 20% came from ASML, maybe in some investment
From
capacity.
Philips, the
Yeah, from
parent of
Philips,
ASML.
the parent of ASML. And so you had this kind of very, not only, as Ido pointed out, not only was it dispersed, but it was also heavily concentrated, right? And so the same thing when you think about other parts of the semiconductor, TSMC doing 90% of the high-end chips, you have this kind of incredibly integrated system. And the other part of it is it's analogous to something I saw in the telecommunications sector, where you had parts of the industry being able to disaggregate, or what you saw in the personal computing industry, where it could disaggregate, right? So you could have in a personal computer, you could have a piece of software that is an operating system. You could have a piece of software that is an application. You could have hardware that is separate with different chip structures. And so you could have different companies producing different parts of that value chain. And that made it a kind of very interesting, that's what enabled Microsoft to grow. So you have this kind of highly disaggregated structure. And what happened in the semiconductor industry was a similar kind of separation, not exactly analogous, but similar, in that you could separate chip design from chip manufacturing. And chip manufacturing is a high fabrication, I think pretty high fixed cost with a lot of really important technical skills in managing those manufacturing operations. And the chip design is on the other side of the equation. And the US still has a very strong position in chip design. So you put all of that around the semiconductor industry into the context of what's happening globally. And I don't disagree with Chris, but I do think there is a trend now. There are strong, strong trends towards what people are calling deglobalization or decoupling. And somehow there's this notion of, okay, we will become decoupled and we will become self-sufficient in this process. And I think that's utterly delusional, particularly in the semiconductor industry. It's not feasible given the structure of the industry and what we just went through to expect that to happen. Now, part of what happened with the Biden administration is that they did pass this CHIPS Act, Chips and Science Act of 2022. And basically it has about $50 billion of direct investment into the semiconductor industry. They believe it will stimulate a lot of private capital into the system as well. And there are some examples where that has happened. I think Micron is said they would invest a significant amount of money. I think Qualcomm and Global Foundries have said they're going to invest money into it. But the reality is the US will, even under the CHIPS Act, it's a little bit, I think the CHIPS Act, somebody described it as a false hope because it's not sufficient from a fabrication of semiconductor perspective. We will never have enough capacity in the US to really fabricate enough chips to be self-sufficient at the quality and at the level and at the cost that needs to be done. So you just can't extract yourself from the global system. So the CHIPS Act basically has that $50 billion. But if you look at global, if I remember the numbers right, if you look at how much will be spent just to replicate the existing structure, I think it's $1.2 trillion. Okay, the fabricating structure. If you look at what's spent annually, it's something like $125 billion. And that's not even accounting for the process of the next generation. Because once you build one of these things, I think your numbers were something like in 2 to 3 years, you need the next generation of fabrication plant, right? So the magnitude of the dollars, even the 50 billion, and if you throw in another 150, which Brian Deese from the National Economic Council, chairman of it, kind of laid out, if you look at that total, it's less than 3% of the expenditures on chip manufacturing, chip design, chip fabrication in the world. So is it really going to have an effect? Probably not much. Okay, what it does help at some level is it changes the dynamic a little bit to a domestic kind of structure that could be beneficial, right? So if you think about what could happen I had this conversation with Larry, and I asked him, who would you support and how would you support them? And his kind of interesting answer was, if TSMC wanted to build a plant in Arizona, I think we should support that as a government. If we had to build one, if Intel wanted to build one in Asia, I would say, no, we shouldn't support that. And so you start to get a little bit of a breakdown of what's a national kind of champion and what's your country interest. Now, I don't think TSMC is particularly comfortable building in the US. They'll probably do it. But I don't think they're comfortable because it's so technically sophisticated, and I'm not sure they can believe they can replicate it in Arizona, but that's a different topic. So you've got two things going on with the Biden administration. One is the CHIPS Act. And I think that's a bit delusional as to whether it's really going to have a significant effect on the US's self-sufficiency in the semiconductor industry itself. The second, which is I don't know if you want me to go into it or wait.
Yeah, maybe we can
You want to wait?
Yeah, maybe we can wait 1 second, because I think there is one point that is interesting about the CHIPS Act, and it's a dilemma that we have also in Europe. This is the title of the panel. There is also Europe. Maybe we should try to spend a few words on it, even if it is less relevant than Asia and the US. Also in Europe, we just passed a CHIPS Act, and people criticize it because they say the target are advanced chips, and advanced chips, tell me if I'm wrong, are used primarily for electronic devices like computers, smartphones, and stuff like that, things that Europe does not produce. Whereas Europe is much stronger when it comes to the production of cars, but you don't need this kind of chips. So the question is not only about expanding production capacity, but it's also about asking ourselves, what kind of chips do we want to produce? And I think it would be interesting if you can tell us, when it comes to US, Europe, and China, where their effort should be directed, in your opinion. Or let's say, maybe let's give away China for a second. Let's focus more on Europe and the US. In China, we keep it for a second.
Okay, well, I guess I agree with everything, John, you said about the impossibility of self-sufficiency. I think that's absolutely right. And if you look at the countries that have the most plausible case for self-sufficiency, like Japan or the US, they're still a long way away from self-sufficiency. But I think that the CHIPS Act is not, although you can find members of Congress who haven't done their homework talking about self-sufficiency, the reality is, I think if you talk to the members of Congress that drove the CHIPS Act forward, and if you talk to most of the Biden administration, with some exceptions, most of them don't think self-sufficiency is the goal. And I think the way to think about the CHIPS Act is the following. Taiwan produces over a third of the world's new computing power every year. The security of that supply is declining. Whatever probability you put on a war in the Taiwan Straits over the next 10 years, that probability has got to be higher than what it was 10 years ago. If we were to lose access to the supply of chips produced in Taiwan, the result would be to throw the world economy into a depression unlike any we've seen since 1929. And so put your probability of a war in the Taiwan Straits and multiply that by the multi-trillion-dollar price tag that just the disruption of access to Taiwan-produced semiconductors would create. And that, to me, suggests that there's plenty of incentive to produce somewhere else. But, and I don't really have a strong view as to whether that production happens in Japan or in Europe or in anywhere else in the world. But I worry a lot when a critical good that we can't live without is only produced basically in one geography. That to me seems like a justification for spending a bit of government money to provide some diversification. And I don't think that really conflicts with what you're saying, is that $39 billion we're spending is not going to dramatically move the needle.
I just want to comment real quick. So I actually agree with what Chris just said. And what you worry about is when you have a global structure where it's coming under increasing geopolitical pressures, where you're moving a bit from what has historically been multilateral collaboration and cooperation to one that's nationalistic and competitive. And I pulled up a couple numbers outside of semiconductors that make me nervous, right? So for example, lithium and graphite used in electric vehicles, right? There are three or fewer countries that actually produce the bulk of lithium and graphite. If you look at natural graphite, pretty broad, but 80% of it is refined in China. If you look at cobalt, 70% of the world's cobalt necessary and kind of high comes from the Democratic Republic of Congo. 30% of the world's nickel comes from Indonesia. 30% of the world's copper comes from Chile. So when you have these, to your point, I think it's exactly right. It's not global in that it's widely spread, but it's global in the sense that there are a few countries and you potentially have these strong choke points. And I think there are choke points in the semiconductor industry. And you're exactly right. That's what we it puts pressure and intense pressure to try to find alternative sources and broaden diversify the base, which is what I would advocate for strongly, right? I mean, the need for diversifying your sources and how you do that, I don't know exactly, but I would say that's.
So, and this is relevant to move to the China topic and the export ban. In the book, you spend the last few chapters talking about the approach that the Obama administration, the last three administrations have had towards China. And basically, when it comes to semiconductor industry, basically the Obama administration at some point realized that it was a hot topic and something had to be done, but they thought that it was just enough to run faster and to outcompete China. Then Trump arrived and it imposed a sanction on Huawei, for instance. And now there was a further escalation with the Biden administration. Maybe, John, you can tell us a bit whether you think it will be an effective strategy from a more economic perspective, and maybe you might highlight the cost and losses for American companies related to it.
So it's an incredibly complicated question. And to be honest, I'm not quite sure what I believe. And I had this conversation with Graham Allison, who wrote his book on the Thucydides trap and China, and, is war inevitable and all of that. And I asked him this question, a version of this yesterday, and he said he was uncertain, that he didn't know whether the policy I'm going to describe is a good policy or a bad policy for sure. But the policy that the Biden administration came forward, the second piece I wanted to just touch base on is export controls around exports to China in the semiconductor industry. And it's actually a very sophisticated, I think, export control proposal. It will certainly have effect in the near term. Longer term, I think it's harder to sort is it a good thing or a bad thing? Let me just tell you kind of what it is really quickly. There are four elements to it, and each one of them is actually really quite important. The first is it tries to create to strangle the Chinese AI industry by choking off access to high-end AI chips. And China can't produce those, at least in volume and with quality at this point. And so they're trying to cut that aspect off of exporting. Second is they're trying to block China from designing the AI chips domestically by choking off China's access to US chip design software, where I think the US still has a lead in kind of chip design. And the third thing is they're trying to block China from manufacturing advanced chips by choking off access to US built semiconductor manufacturing equipment. And this gets more complicated because we'll come back to it maybe, but if you think of ASML, which produces these lithography equipment, and they're a Dutch company, what's their obligation under these export control kind of elements, if any?
They're very unhappy.
And they're very unhappy because this is a major market for them. But they don't necessarily want to annoy the United States. So it's complicated for them. And then the fourth piece is to block China from domestically producing semiconductor manufacturing equipment by choking off access to US built components. And if you think about, and I keep coming back to ASML because I found it so fascinating in the book, but ASML is got this strong intellectual property. But I think one of their strengths is that they've orchestrated a very complex supply chain as well. And so I think that the number was something like over 400,000 parts go into one of their lithography machines. And many of those parts are manufactured by other companies that are in the ASML value chain. So it's a very tight, so they're trying to cut off the access to the components, to the lithography machines, to the AI chips. And so it's a kind of across the value chain, or the supply chain, if you will, effect to cut off export controls. Now, the criticism that's bubbled up about the policy is that it may in fact lead China to become more independent, to invest themselves in building all this capacity. I will leave it to Chris to tell me whether that's a 5-year proposition or a 100-year proposition or not feasible. But I think that's the nature of the criticism. I guess where I come out is, and I'll talk maybe more a little bit about what I think should be done, but I'm not necessarily wild about things that are anti and try to cut back on competition versus things which facilitate competition constructively. And so I don't know where I come out exactly on this export control piece. I'd be curious to hear if either of you have a view on it.
So I mean, I think economic suppression, because this is what we are talking about, is a very dangerous policy. This is my perspective, because it's very likely that China at some point will retaliate. And as you were mentioning before, listing all the kind of raw materials the West is depending on China, I think it's a very dangerous proposition. And I mean, I'm curious to hear also Chris, because the book was released just before both the CHIPS Act and the Export Ban were implemented. But I guess if there is a new edition of the book, you might end up adding a chapter or two on this topic. So can you give us a preview of what you expect to write on the export ban in particular?
So I think to understand where the export controls came from, most chips today, 98% or so, go into smartphones or PCs or consumer devices. But there has historically been an ironclad relationship between advanced computing power, intelligence agencies, and military power. Whether it's from the first chips that went into the guidance computers on the missiles intended to deliver nuclear warheads to the Soviet Union, whether it's the fact that during the Cold War, we now know that the NSA in the US and the KGB in the Soviet Union had privileged access to their most advanced computers. I think it's undeniable historically that every great power that has had access to advanced computing has deployed it in their intelligence capabilities and in their military. And so the question, I think, is to what extent are you worried about the military balance in Asia? And then to what extent do you think that what has been true historically, that there's been a major influence of computing power on military power, to what extent will that stay true in the future? And when I look at discussions about the future of military systems, I think intelligence is sort of obvious the ways that computing power will be used for hacking, for encryption. This dates back to World War II. The first computers deployed in World War II were to break codes in the UK. So I think the intelligence ramifications of advanced computing is pretty obvious. But on the military side, if you ask yourself, what are the systems that defense officials in Beijing, in Moscow, in European capitals, and in Washington are investing in, they're focused above all on thinking about ways to apply autonomy and artificial intelligence to military systems, which means that the ability to access the semiconductors that make AI possible will be fundamentally important in shaping which countries have access and which countries do not. Now you can say, well, we don't see it yet in the battlefield. Maybe that's true. But I think you'd struggle to find someone in defense industries who would tell you that they're not already seeing systems being designed that rely on more computing on board in the edge, and also more computing in the data centers that are training drones to fly smarter and training missiles to fly more accurately. And so if you believe that the future of military power will depend more than ever before on computing power, and if you believe that advanced data centers, which is where AI systems are trained, will be critical to the future of military systems that are going to be smarter and more autonomous. And I think it's not that hard to draw a pretty straight line between who's got the best data centers and who's got the best military systems. Just as like no one would contest the fact that in the early Cold War, there was a pretty close relationship between the ability to develop nuclear technologies and nuclear weapons systems. Now, the difference is that unlike in the past where we had export controls on missile components and on nuclear isotopes, today we're putting export controls on machines that are used both to produce military power and to produce smartphones. So it's a different world in that regard. We're intruding much deeper into dual use territory. But the typical person, I think, including many in this room, probably struggle to think of the ways that chips and the computing enabler are used in military systems. But I will tell you, the typical defense planner has a very clear line of sight into the ways they want to deploy a lot more computing power, a lot more data center capacity into their military systems. And so that's why there's pretty much unanimity across the US government, and there has been for the past 5 years, that there needs to be more done to protect the remaining advantages that the US has, especially in a context in which the Chinese military is expanding quantitatively. And the Pentagon released its the recent annual China military power report that tracks the number of ships in the Chinese Navy and airplanes in the Chinese Air Force. There's no doubt that the Chinese will produce more ships and planes and missiles over the coming decade than the US will. And especially if you look at potential crisis points in Taiwan, China's got all of its military power deployed right there, whereas the US has to divide it between the US and Europe. So the US is at a quantitative advantage. Its only hope is to try to retain what exists of a qualitative advantage. I think it's a pretty plausible case that the best qualitative advantage that the US has is in computing power.
Do you want to react? Or?
Yeah, I completely agree with kind of that part of the equation. And so that's what makes this actually a quite difficult problem, because I think of these things oftentimes from my background, which is running companies. And, you know, these kinds of decoupling or kind of the separation, it may impede the operations of these players like the MNCs, where they're going to face inconsistent and contradictory rules and standards, and even heightened legal liabilities, right? So there's that risk to companies. Part of the result of that and the increasing complexity and rising costs of operations may actually weaken companies' willingness to invest. And then it will have adverse effects on global productivity, right? So that's why I said I'm not sure how I feel about the export controls, because you're balancing some of these things you described, which are very, very real, against the impact on the global economy, the impact on innovation, which has always been one of the major sources of growth for the global economy and any individual country economy. And that's what makes it hard for me to kind of sort through.
So thanks. In a second, we will start taking questions from the audience. I have one last question for you. I think there is another chapter that is missing in your book, and you might consider to add it in the next edition. A chapter about the future of the industry. You somewhat mentioned something right now, but if I may ask you about my final question, how do you expect the semiconductor industry to look like in 10 years from now? You can say anything because we will all forget it, so no worries. Even if we will go on YouTube.
Yeah, let me answer a slightly different question, but maybe it'll get to what you're looking at. I think on the structure of the industry, I guess my bias is to expect actually the structure to look surprisingly similar in terms of a small number of machine tool makers capable of making the machines that make the chips. A larger number of firms designing chips, a lot of concentration in chip manufacturing. I don't see that changing. Although who knows, I could be totally wrong. I think the other interesting question is, how long will Moore's law persist? And this is absolutely critical.
Can you tell them?
Yeah, so with Moore's law, Gordon Moore, founder of Intel, predicted in 1965 that the amount of transistors per chip would double every year or two for the next decade. He was right, not only for the next decade, but all the way up to the present. So that's what's made it so that the first chip commercially available had 4 transistors on it, and the chip in your iPhone has 15 billion, the doubling every 2 years. And right now they've doubled to the point they doubled to because they're made very, very small. And at some point we're going to have transistors that are so small it's physically impossible to manufacture them. Now we're not there yet, but we're getting frighteningly close. And it's possible that by 2030 or so, we just can't find ways to make smaller transistors. And if so, our access to more computing power would grind to a halt. We'd have to have bigger chips rather than smaller transistors. And miniaturization would go in the wrong direction. Power consumption would go in the wrong direction. There's a lot of really negative side effects that flow from that. So there's a huge question: can we sustain Moore's law? And I think to John's point, any inefficiencies you throw in the industry make that harder and harder. So that's the big risk I see actually of the industry, is that technology doesn't advance the way that it used to.
Do you want to give us your preview about the future, or
No.
Okay.
I
It's a smarter
prefer not to
answer, yeah.
predict the future, since I'm usually wrong. But just a couple of things. You know, I don't want to leave on such a negative note about, like, I don't know what to think about the Export Control Act. I mean, I do think there are things that the government can do and should do, and particularly thinking about the US. And one is, there needs to be an effort not to think of nationalistic competition, but to how to build collaboration coalitions of the willing with like-minded views on supply chain structures and geopolitics, right? I think there are things that can be done there. I think just encouraging competition, I think can maintain some of the innovation within that context of partners. I think the US is failing on immigration, and increasing the number of highly skilled immigrants coming into the US is an important step. I think supporting the expansion of training facilities and university STEM activities is critical in the longer run, and potentially even more money into R&D, either through R&D tax credits. Most economists, if you ask them what kind of tools support innovation, they'll tell you R&D tax credits, they'll tell you direct R&D grants, enhancing trade and competition, and skilled immigration and university STM. And those are things that could be pushed forward. And I don't want to make it sound like the Biden administration isn't thinking about these things. And I had pulled up for myself, and I happen to know Brian Deese a little bit, and as the chair of the administration's National Economic Council. And he said, he basically gave a speech, and he was talking about industrial policy a little bit, but he said enhanced engagement with our partners abroad is a matter of economic and geographic necessity. It's neither feasible, to your point earlier, it's neither feasible nor advisable for us to produce everything domestically. We need international coalitions of reliable partners that reinforce secure supply chains and amplify our own sources of strength, which I completely agree to. This is also a matter of geopolitical necessity. America's national and economic security is bolstered through strong alliances. We're fully engaged in supply chain diplomacy. Let me be clear, this is about strategic engagement, not isolationism. I agree with that. I mean, I think that's the right mindset. Now, how you implement against that mindset is a much more difficult question. So.
Yeah, building on what you just said about immigration, and then I promise that we come to you. I think it's interesting because in the book you highlight that some of the key actors in the semiconductor industry were actually immigrants. Morris Chang is one example, but also Andy Grove, the CEO of Intel. His real name is actually Andras Grof, because he was from Hungary and he just migrated here. So I think also thinking about immigration and the importance, looking at the history is really key. So we have probably something around 20 minutes for questions from the audience. So if you can just introduce yourself.
Yeah, my name is Michael from Harvard College. Thanks so much for being here. I have two questions. So the first one regarding China and the industry. Why is it so difficult for China to replicate some factory from TSMC? Because so far in almost all different industries, they were able through joint ventures, through spillover, human capital, industrial espionage, etc., to do that. So what is here really the main point of getting Chinese actors not to hack into one of those factories and like just copy that? And second question regarding the importance has been pointed out, I think, a couple of times. So is this a factor that is going to, in the worst case, that hopefully will never happen, but a military action from the Chinese side to disencourage them because of the economic damage that oneself would suffer through NOMA being able to access TSMC?
I think it's for you.
Sure.
On the replicate, I may have a comment on the second part. But.
Okay, great. Well, on replication, I think there's a lot of advanced manufacturing sectors where replication, copying is just really hard. And I don't think there's a challenge that people often ask me, why can't China replicate what Taiwan does. Well, no one can replicate what Taiwan does. So it's not just a China problem. And it's not as simple as copying and pasting, because there's so much tacit expertise in the brains of the individuals who are working in TSMC's facilities. And the same thing is true for ASML or for all the other companies in the supply chain. So there's no file you could copy and email to somebody else that would give you the secret sauce. It's not written down. It's in the unique skill sets of the employees. And so you really need to kind of copy and paste all the employees too, as well as whatever files you found to try to replicate the facilities. And even then you need the machine tools. And the machine tools themselves present their own process of extraordinary challenge to replicate. So there's nothing sort of in the Chinese manufacturing sector that's not working well. Many of these, the tools, the software, the manufacturing processes are not replicated anywhere in the world, and they can't simply be copied and pasted. It's just not that simple. On the role of Taiwan's criticality, and does that deter war? Look, I hope the answer is yes, and maybe it is. The Taiwanese president, Tsai Ing-wen, calls this the silicon shield thesis. She's not the first to use this phrase. The idea being that Taiwan is a critical supplier of semiconductors to the whole world, including China. So therefore, the world will find a way to prevent any crises. Look, maybe that's true. But I also think there's a good chance in the type of crisis that is most likely to emerge, Taiwan's centrality doesn't deter China, it deters the United States. If you think the most likely crisis is a D-Day invasion, then maybe the Silicon Shield thesis is relevant. But I think the most likely crisis is not that type of invasion, both because it'd be very, very hard, as all independent military analysts suggest, and because it would obviously trigger a US response. Whereas if you do something smaller in the Taiwan Straits, grab, for example, one of the small uninhabited islands, it's far less clear what the US response would be, which makes it a far smarter strategy. I think the analogy here is to what Russia did in Crimea in 2014, which worked, versus what Russia did to Ukraine in February, which hasn't worked. And in that type of scenario, a sort of Crimea 2.0 with a small Taiwanese island, if China manages to grab an island, salami slicing away Taiwanese sovereignty, and looks to the US and says, all right, your move. The US president will get a briefing that says, dear Mr. President, you can either risk World War III and destroy the world economy by escalating militarily in the Taiwan Straits, or do nothing. And by the way, your next midterm is 18 months away. In that scenario, there's no doubt that Taiwan's centrality deters the United States. I think it's wrong. I think it's wrong to think the Silicon Shield is real in the scenarios that actually matter.
John?
No, I was just going to say on the replication question, if you look at how the early days of the semiconductor industry, as you outline it in your book, people didn't actually completely replicate, I don't think. I think what they did was integrate, as you describe it, and as others have described it. They figured out how to integrate in and provide pieces and eventually expand. And so and then all the things that Chris said about the difficulty of replicating, it's not just like capital, it's the embedded knowledge and the learning curve that these facilities have gone up. And so that you have a combination of high fixed costs to get into the game, combined with incredible knowledge and intellectual capital that isn't simply easily transferable, that make it just very difficult to replicate. I mean, I just think it's not doable. But
thank you. I have a quick. Maybe we can grab two questions at the same time.
Hi, I'm Margaret Sue. I'm from the law school. So thank you so much for speaking. I was curious, flipping to Taiwan's side, if you could get policy recommendations for the Taiwanese government on the future of protecting and advancing their silicon shield, as you mentioned. What would you say? And a question that I've been thinking a lot about is how much agency does Taiwan actually have in the matter? And talking with quite a few experts on the Taiwanese side, there's a lot of hesitancy to whether or not they even have the capability of saying no to the US. So I'm quite curious what your take on that is.
Thank you. Should we go for a second one?
Hi there, my name is Richard. I'm a joint degree with the business school, taking a class with John right now. So one follow-up question on your sort of the strategic thinking. You were talking about sort of chipping away versus a full-scale.
Can you speak louder? Sorry.
Chipping away versus a full-scale invasion. How do you think about the strategy of, say, China explicitly saying that they would allow TSMC to continue to operate as normal, like in the case of an invasion, which I think changes the calculus around what a silicon shield would mean, which is to say that they want to stay involved in the global economy, don't want to like disrupt the supply chain, but still want to continue to advance sort of their interests in trying to take over the country.
So on the question of Taiwan's optimal strategy and agency. So a couple thoughts in response to a complex question. On Taiwan's optimal strategy, I mean, I think there's two questions here. There's an economic strategy and a defense strategy, and they cut in potentially different directions. And my sense is that I don't think the Taiwanese government has taken defense sufficiently seriously, given the deterioration in position in the Taiwan Straits. And so I think if Taiwan were to do more on the defense side, and also if the US were to do more on the defense side, we would all be worrying less about the possibility of war. And so we would be focused less on the geography of semiconductor manufacturing. If it was 10 years ago and my estimation of the risk of war was not that far from zero, I wouldn't really care much where chips were manufactured. It's only because the military balance has swung so dramatically, coinciding with Xi Jinping's leadership, which has led to all the dramatic expansion, I think, of China's ambitions in the South China Sea and the threats to Taiwan, that we're all increasing our estimation of the likelihood of war. So if we were able to return to a strategic position of, say 2000, we wouldn't worry about the geography chip making. So I think the first question is, can we get back in that direction by increasing Taiwan's defensive capabilities and by increasing America's ability to credibly defend Taiwan, which is a promise that the US makes, and Biden has made now 4 times implicitly, which becomes ever less credible as every day passes. And that's the key problem. I think when it comes to Taiwan's autonomy, I think there's no doubt that the Taiwanese government feels under pressure from the US, and I think it certainly is. I think in addition to that, and possibly more important, is that TSMC is under pressure from its customers, who are undertaking the same calculation themselves. What's the risk of disruption in the Taiwan Straits? And as Apple's CEO Tim Cook has recently said publicly, he wants more production in other geographies precisely for that region. But they're responding to the same shift in the strategic calculus as policymakers are. And so if there were a way to reverse the deterioration in the Taiwanese and American defensive capabilities that's happened in the last 10 years, and thereby reduce the risk of war, then I think we would all be less worried about where TSMC is actually making its chip. So I think that's the complex relationship between the strategic level question and the TSMC level question, but they are inextricably interlinked, I think. On if something bad happens and there is a Chinese attack, I think it's highly unlikely that any chip facilities would survive an attack, close to a 0% probability. Both because you need the personnel there, you need the machine tools, the most precise machines ever invented in human history to still work, which seems implausible. And then you need regular supplies from Japan, the US, other countries to keep those factories in operation. You need the Taiwanese government not to blow them up, and you need the US government not to blow them up. And those are a lot of conditions to meet, which puts me at a 0% probability that TSMC facilities survive a conflict in the Taiwan Strait. So I actually don't worry that much about. People ask what happens if China takes that's a non-plausible scenario. Much more worrisome is what happens if we all lose access to the chips that we all depend on. That's a really scary scenario.
I mean, first of all, let me caveat, this is not really my area of expertise, and there are people that know a lot more about Taiwan than I do, and the China-Taiwanese relationship. A couple of things have jumped out at me in the course of conversations with individuals. One is that the situation in Taiwan from a cultural perspective is changing. And for a long time, Taiwan, the older population of Taiwan were people who had gone with Chiang Kai-shek from the mainland to Taiwan. And so there was a much more kind of historical, cultural relationship, a lot of familial relationships between Taiwan and the mainland. The people that have been on Taiwan, the younger people today, don't quite have that. I've been told, and I'd be curious if anybody here has better perspective, but that they don't quite have that same familial kind of connection back to the mainland, and they tend to see themselves as a little bit more of an independent country. And so that kind of changes the expectations a bit. What Chris was talking about in terms of hard to see the TSMC factory fabs surviving any kind of actual physical all-out war, I think is right. And so it's almost a version of the World War II mutually assured destruction. That, you know, I think you're hesitant on the silicon shield kind of notion, but it seems to me that it's in really no one's interest to have these factories not continue to operate in some way, which actually does provide a little bit of protection around some kinds of actions by China against Taiwan. You have hesitation?
Well, I would just say that the Germany and Britain were each other's two biggest trading partners.
Yeah, Germany and Britain were big trading partners, absolutely true. But it does kind of like, what if China decides not to invade, but they blockade, right? And so then some of the equipment and some of the other materials that need to flow into Taiwan simply can't reach Taiwan. You know, that would be the kind of chipping away at the relationships and creating certain pressures along those dimensions. I think it's a very potentially explosive moment. And I hope that the notions of collaboration can actually come to the forefront somehow. Again, not to dwell on Larry Summers, but he and I were talking about this, and he used this description, which I find helpful. And he said that basically the relationship of the US and China is a little bit like two individuals in a rowboat on the ocean. And they really don't like one another much. But there are two oars, and if they don't row together, the seas are kind of choppy and they're going to crash on the rocks, right? So how do you figure out ways that, even though you may not necessarily like the other person, you got to figure out how to row together so that you don't kind of crash yourselves and the global economy in some ways on the rocks and other even more severe kinds of ramifications.
Thanks. Are there other questions from the audience? Probably there. Also here in the front.
Thanks for the discussion. Jacob Drashina. I'm a mid-career student at HKS. I'm wondering, we discussed about the Export Control Act, and that's one of the most comprehensive packages to stem Chinese development of semiconductors. I'm wondering, in the future, if China's been able to, let's say, keep developing its industry despite these export controls, what options do American policymakers have to make these export controls even stricter? Not assigning a good or bad value, but what would the options be? Thank you.
We have probably here in the front.
Thank you. I am Juan José García, fellow at the Water Center. My question is about the efficiency of the public investments foreseen in the CHIPS Act, but also in the European CHIPS Act. Basically, the United States went solo. It's not the first time. It's also happened with the car batteries, for instance, in the area. So my question is, there will be any ways to cooperate between, let's say, Europe and the States, because the fundamental problem is the same. We need to diversify the manufacturing points. Whether the new manufacturing will be located in Europe or in the States will enhance the security of supply chains for both actors. Is there any way to spend this public money maybe together in a more efficient way to obtain a common goal at the end?
On this, I may answer that it's already difficult for European governments to decide where to spend their money across the different jurisdictions. It might be even more complicated to decide where to spend the money with the US. But hopefully, I mean, I think that's the direction from a European perspective. I think the problem in general right now with the Biden administration is that we see it moving along without engaging its European allies. And this is certainly a problem, not just for the chips, not only for the semiconductor industry, but for many other things. Also, the Inflation Act has created a lot of problem between the two continents. But I let you, Chris and John, respond to the first question, or also this one.
I'll refrain from commenting on the IRA since that's far from my area of expertise. But on semiconductors, I think actually I would tell the reverse story, which is that the US has been trying, so the thesis of the Trump administration was that it's not worth working with the Europeans because they're slow and they never do anything. And the Biden administration came to office and said, let's
true. I have
well,
to say that.
let's test that.
This is
Particularly
one of
in
the
Italy.
few things I agree with.
I'm not endorsing that, just that was the thesis. And the Biden administration, to their credit, said we want to work with allies. And so they set up the Trade and Technology Council between the US and the EU, which has now met several times. And one of the key areas the US that it was focused on was semiconductor export controls. And conversations were had, discussions went were ongoing, and the Biden administration eventually acted unilaterally on export controls, despite a lot of consultation that didn't really reach results that the US was hoping for. So I think it's probably not accurate to say that this was a failure of the Biden administration to consult with European allies. I think this was a failure of the consultation process to produce results. And I think what's striking to me is if you compare US-Japan collaboration on semiconductors to US-EU, I think there's a lot more alignment between what the US and Japan are doing than the US and EU are doing. And I would hypothesize that the EU is the outlier among those three big players. So I think I asked my European friends to ask themselves, can they articulate what the EU Chips Act is going to do? Not yet. Is anyone in the European chip industry confident in the supply chain interference mechanism that the Chips Act has? Well, no, the European industry thinks it's a horrible idea. So I think the EU chip policy is in the wrong place. And the fact that the US is moving on its own is not due to the failure to consult.
Yeah, just to add to that, I know the Biden administration over the summer met with 18 different countries collectively. And the focus was really to make the collective supply chains more secure, more diverse, more resilient, more sustainable. So I think Chris has it exactly right in the sense of it's not an effort to engage. I think that effort is there. I think it's, can they actually get some results out of that effort in a constructive way?
Yeah, probably we have time for one or two more questions, and then we wrap up. Ted here in the front.
So, all of it very interesting, somewhat depressing. I'm Ted Truman. I'm a senior fellow at the Massabar Ramani Center for Business and Government. So tell us something about the geography of in Taiwan and where the manufacturing is located.
Yeah, I don't know that.
Yeah, because I mean, you could, I mean, it's not, I mean, the Silicon Shield idea makes some sense, right? If in some sense they destroy the manufacturing base, right? It's not like Ukraine and the power system, right? It doesn't impact Russia, right? But if you destroy the chip industry, the final phase stage of the chip industry in Taiwan, as you said, everybody loses, including China, even though it may lose more indirectly than the West. So the question would be whether there's some way to invade Taiwan and avoid affecting the location of the industry. Okay, well, that's possible.
Yeah, probably have time for one more question, but it has to be brief, and your answer has to be extremely brief. So.
Hello, I'm Wayne, HKS dually with MIT Sloan. I'm in a startup right now, and we're facing a dilemma of design. We're about to design chips, and we need to choose a fab. And frankly, TSMC is not great for a couple of reasons. They're great for cost, great for advanced technologies, but for IP, we have some ITAR things that we might have to work through, and obviously the geopolitical situation. So can you briefly describe, if successful with the CHIPS Act and the European version, what the landscape of the other foundries, the other fabs would look like? Thanks.
You have 30 seconds each, so.
I'll leave that one to Chris.
Well, I will just say that this challenge of finding ways to fab chips designed by researchers and startups is a key challenge that I hope the Commerce Department team will address when they spend the R&D funds. There's a number of proposals right now to either expand or open up new fabrication capacity specifically designed for startups and researchers. So maybe we can talk afterwards about specifics, but this is a key a key challenge for the US, because right now it's easy to design, or not easy, but easier to design, really hard and expensive to fabricate. So we get less fabrication than we would like, fewer prototypes than we'd like, less innovation than we'd like because of the cost of fabrication. So I think there's a lot of work to be done this year. Perhaps we can touch base afterwards on details.
John, last word.
I'm good.
Great. So I want to thank everyone for showing up. I want to thank John and Chris. I forgot to say thanks to Chris because he brought some free copies. Some of you were lucky enough to get them. I'm sure you are happy to sign them if you wish. He will be very famous. He's already famous, so it will be very valuable. And just for you to know, on Monday, he will be in London for a gala dinner organized by the Financial Times, when the Financial Times will announce the winner of Best Book of the Year, and he is shortlisted for the prize. So best of luck on that, and thanks everyone.
Thank you.